Today we will go into the second chapter, which is the linear second and higher order differential equation. So basically what we are going to learn in this chapter is similar to the first one. Okay, so just a quick recap. Okay, in chapter 1 we have in chapter 1, okay, what we did was from the equation, the derivative here, we want to reduce and get what is y. Okay, so there are a few methods that we have to know in order for us to do the solution. Okay, we have seen the separable, homogeneous, exact equation, linear equation, and Bernoulli equation. Okay, so that was what we have learned in chapter 1, sorry. Now in chapter 2 we are going to learn the similar concept, okay, where we are going to reduce the second order or the third order or the fourth order differential equation and reduce it to get what is y. Okay, so basically this is what we are going to learn in chapter 2. So let's just start. These are the contents. You will be introduced to the basic definition and terminologies. What are the homogeneous equation? What are the non-homogeneous equation? Okay, for non-homogeneous, there will be two methods that we can use. The first one is the undetermined coefficient. The second method is the variation of parameters. And after that, we will look at the applications of second order ordinary differential equation. Now let's have a look at the first part of the chapter, which is the basic definition and terminologies. By now, I think you already understand what are the linear differential equations. We have seen this in the first chapter. Okay, but that one in it is up to the first order only. Okay, but this one it will be higher order, so that's why we have d and y, dx and so on. Okay, so basically this is the linear differential equation with the dependent variable y and its derivative here, it has the degree of 1. Okay, and all the functions an minus 1, a1, a0 are all the coefficients for the derivative. And the fx on the right hand side here is a function in terms of x, which is the independent variable. So if the function here is equal to 0, then the equation is called the linear homogeneous equation. So remember, fx0, homogeneous equation. Okay, but if it is non-zero, meaning it is a function, then it is a non-homogeneous equation. Alright, so the combination of solution, if y1 and y2 are linearly independent and each of them are the solutions for the differential equation, then the general solution for the differential equation is given by the combination of these two, y1 and y2 here. Okay, but the condition that have to be met is y1 and y2 are linearly independent. Right? And then we have the linear superposition principle. Basically, it's just the same concept. This one is y1 and y2. Okay, but however, if we have more than that for the higher order, then we will have more function, more solutions. So y1, y2, y3 and so on are linearly independent. So each of them will become the solution for the differential equations here. then the general solution will become the combination of this solution of y1, y2, y3 and so on. Okay, so let's have a look at the solution for the homogeneous equation. So remember, when we see the word homogeneous equation here, okay, in the second chapter, it means that our fx is equal to 0. Okay, so this is what we have here. Okay, the equation of second order differential equation is equal to 0. So our aim in this section is to find the solution for the differential equation. So to find the solution, when we see the word to find the solution, so it means that we want to find what is y. That is the solution we are looking for. And since this is second order, meaning that we will find two solutions. Okay, two solutions, so it means that our y eventually will be a combination of a y1 plus b y2. Okay, it depends on how many orders that we have. So assume the solution is in the form of this, y equal to emt. Thus, when we differentiate dy dt, this is what we will have. Okay, so if the solution to 1 here is y equal to emt, thus it must satisfy this one. Therefore, if we substitute all the terms in 2 and into 1 here, okay, all the substitution here we put inside the equation here, eventually this is what we will get. Okay, so this is what we call as auxiliary equation. So to solve the auxiliary equation, what we have to do is to find the roots, because it is a quadratic equation. Once we find the roots, all right, because this is a quadratic equation, of course we will have two roots, m1 and m2. We can use this formula. However, there are three types of category for the numbers. It can be a real number, it can be 0, which is equal number. Okay, it will give an equal value, or it can be a complex root. So whatever the value of m1 and m2, it will give us the solution, okay, according to the category of the number. Now let's have a look at one case. The first case is where we have the real root and distinct. It means that we will look at this category. Oh, sorry, not that one. This one. Roots are real and distinct. So it means that m1 is not equal to m2, which means that we will have two different roots. Okay, let's look at the first example. So we know that this equation can be reduced into the auxiliary equation in this form, this one. All right, see, when we have y double prime, and we will have m square. When we have when we have y prime, when we will have m. And for the y here, it means that it is m with the power of 0, so it's 1. Okay, it's 1 here. So use the characteristic equation that we obtain. Okay, we can find the roots. So this one can be easily guessed, the roots, because we can directly do the factorization. And there are two different roots, which is m1 negative 3 and m2 negative 2. So therefore, the general solution is y equal to ae negative 3x plus be negative 2x. Okay, and why suddenly we have to have the e here? Because if we look at the definition here, okay, we assume that the solution is in the form of y equal to mt. So when we got the m value, all we have to do is substitute into the y equation here. So we get y equal to em1t or y equal to em2t, just like that. Alright, so let's have a look at one example here. So we have y double prime minus y prime minus 11y. So what we have to do here is, first of all, transform it into the characteristic equation or auxiliary equation. So in this case, we will have m square minus m minus 11 equal to 0. And from the equation here, we cannot directly do the factorization. So what can we do is, we can use the formula m1, m2 equal to negative b plus minus z b square minus 4ac over 2a. We can use this formula to find the roots. So substitute the value. Alright, we have negative 1 plus minus negative 1 square minus 4ac. Okay, over 2a. Alright. Some of you might not remember what is the value of A, what is the value of B, what is the value of C. Okay, you can have a look at the equation here. Okay, A is the coefficient for m square, B is the coefficient for m, and C here is the function here, coefficient here. So we can just substitute the value, negative B, okay, plus minus B square minus 4AC divided by 2A. Okay, so that is the formula to find the roots. So once we get this, we will have m1 equal to 1 plus 3 5 over 2, and m2 equal to 1 minus 5 over 2. Okay, how do we get plus minus? We got it from the symbol here. Okay, so we have to split. One is positive, one is negative here. Okay, some of you might got confused. Why suddenly I have 3 and 5 there? So it's all come from here. Alright, this is actually Z. What is it? 1 plus 44, is it? Right? So this is actually Z 45. Okay, Z 45 is equivalent to Z 9 times 5. And this can be splitted into Z9 and Z5, where Z9 is given by 3 and Z5 can remain as Z5. Okay, so that's how we got the value. Alright, so now we already know what are the value of M1 and M2, and after you use your calculator, you can actually see that the values are distinct. It's different values for M1 and M2. So that's why we can write down our final answer, Y homogeneous is equal to A, E, and then put the value here for M1, 1 plus 3 Z5 over 2 X plus B, E, with the power of 1 minus 3 Z5 over 2 X here. So that is the answer for homogeneous equation. Okay, next we have the second case where our roots are real and equal, okay, which means that m1 equal to m2. So whenever we have this root, this is how our general solution should be. Okay, it's the same roots. So you have to remember and memorize this. Again, the first step is to transform all the differential equation here into characteristic equation. So this is the characteristic equation. Okay, we have the m squared plus 6m plus 9 equal to 0. And this one can be factorized directly like this. M plus 3 squared equal to 0. Okay, and this one we can actually have 1 plus 3 m plus 3 equal to 0. So that's why we have m1 equal to negative 3, m2 equal to negative 3. So it has the equal value. So therefore, we follow the solution with the equal value here. See, we only have one value of m, and the value is the equation for the solution is given like this. Okay, please check. Okay, we use the m value here. Alright, so now let's have a look at the example. Oh, no example for this one. It's okay. We'll see more of the example after this. The third case is where the roots are complex number. Now let's try and transform the differential equation into characteristic equation. We have m squared minus 10m plus 26 equal to 0. We cannot do the factorization directly here, so just use the formula. Okay, negative b plus minus cert b square minus 4ac divided by 2a. So from there we can find the roots, and this one, all right, we will have a negative value. Okay, negative 4. So with the negative value, our solution will be given in the imaginary form. Okay, so this one, when we split here, we will have 10 plus minus cert 4 cert I square. Alright, that will give us, this is over 2. That will give us 5 plus minus cert 2 cert I, no, not cert I, cert 2 pula. This will give us 2i over 2. That's why we got the final answer f plus minus y, like this. So from here, we determine our alpha and determine our beta, and the final answer for the complex root is this one. Okay, this one you have to memorize. Okay, see the alpha, the real value is here, but the imaginary value will be inside the trigonometric function. So that's why we have, okay, e 5x a cos x, okay, plus b sin x. Now let's look at the example for this particular case. First of all, transform the differential equation into characteristic equation. Okay, so this one will give us m squared plus 6m plus 16 equal to 0. Okay, so we can use the formula m equal to negative b plus minus cert b square minus 4ac divided by 2a. Okay, so this will give us negative 3 plus minus cert 7i. Since this is an imaginary number, the general solution that we will write is y homogeneous is e negative 3x a cos 7x plus b sine 7x, like this. Alright, and don't forget we still have the initial conditions to be used here. So use the initial condition. We will have the first condition is when t equal to 0, then y equal to 1. So use this initial condition. It's 1 equal to e, sorry, this is t. Is it t? Is x. It's not mentioned whether it is t or x, so let's just take to x. Okay, so e 0 a cos cert 7 times 0, or I can just have cos 0 here to avoid confusion. Okay, cos 0 plus b sine 0. Okay, sine 0 will give us 0, cos 0 will give us 1. So therefore we obtain that a is equal to 1. So when a equal to 1, then the new equation will be y homogeneous equal to this like this. Okay, next, the second condition that we have, if you look at this question, we have y prime 0 equal to 0. So it means that x equal to 0, then y prime equal to 0. So first of all, we have to get what is the y prime. Okay, so yh equal to, okay, to get y prime, we have to differentiate. We can use the product rule formula u v. So we have here u v prime would be u v prime plus v okay, u prime, like this. So once we have this y prime, we can use the conditions, which is this is 0 equal to e with the power of 0. Here we have negative 7 sine 0 plus 7 b cos 0 plus with negative 3 e with the power of 0 cos 0 plus b sine 0. Right, and we know that sine 0 is 0. Okay, so what's left is cos 0 is 1. So when we write down the equation, we will have 0 is equal to cert 7b minus 3b, 3a, sorry, minus 3, sorry. Okay, so from here we can get the value of b equal to 3 over 7. Okay, so when we fill in the when we write down the new equation, then this is what we will have. Yx equal to this equation, a equal to 1 and b equal to 3 over 7. Okay, okay, so let's take a break.